Potassium-40 is a radioactive isotope of potassium which has a very long half-life of 1.251 times 109 years. It makes up 0.012% of the total amount of potassium found in nature. Potassium-40 is a rare example of an isotope that undergoes all three types of beta decay. About 89.28% of the time, it decays to calcium-40 with emission of a beta particle with a maximum energy of 1.33 MeV in an antineutrino. About 10.72% of the time, it decays to argon-40 by electron capture, with the emission of a 1.460 MeV gamma ray and a neutrino. The radioactive decay of this particular isotope explains the fact that argon is the cheapest totally noble gas available. Very rarely it will decay to 40R by emitting a positron and a neutrino. Potassium-argon dating. Potassium-40 is especially important in potassium-argon dating. Argon is a gas that does not ordinarily combine with other elements. So, when a mineral forms, whether from molten rock, or from substances dissolved in water, it will be initially argon-free, even if there is some argon in the liquid. However, if the mineral contains any potassium, then decay of the 40K isotope present will create fresh argon-40. That will remain locked up in the mineral. Since the rate at which this conversion occurs is known, it is possible to determine the elapsed time since the mineral formed by measuring the ratio of 40K and 40R atoms contained in it. The argon found in Earth's atmosphere is 99.6% 40R, whereas the argon in the Sun, and presumably in the primordial material that condensed into the planets, is mostly 36R, with less than 15% of 38R. It follows that most of the terrestrial argon derives from potassium-40 that decayed into argon-40, which eventually escaped to the atmosphere. Contribution to natural radioactivity. The radioactive decay of 40K in the Earth's mantle ranks third, after 232Th and 238U, as the source of radiogenic heat. The core also likely contains radiogenic sources, although how much is uncertain. It has been proposed that significant core radioactivity may be caused by high levels of U, Th, and K. 40K is the largest source of natural radioactivity in animals including humans. A 70 kg human body contains about 160 grams of potassium. Hence about 0.000117 times 160 equals 0.0187 grams of 40K, whose decay produces about 4,900 disintegrations per second continuously throughout the life of the body.